Hello, this is Dr. Rahman Ali, and we are going to explain a few commands from SQL data definition language, how we could create the database, then the database object tables with the create statement, data types, constraint, and within the constraint, we will be looking for integrity constraint and some other constraint. This is a lecture followed by a lab for the practical implementation of these concepts. This is chapter number 8 of advanced SQL and data definition language, which is one of the key part of the SQL. Normally, the data definition language talks about create, alter, and drop. What to create table, index, and view, what to alter table, and what to drop all these object table, index, and view, and we will be discussing them in the subsequent lectures. So this is the schema which could be implemented, and we will be practicing customer and invoice, and invoice we will call it order, to demonstrate the different concepts, and particularly the constraints and the integrity rules. The create command is used for creating the database. For example, if I am going to create a database with the name celldb, then how I could use it. This is the statement, create database, and this is the name of the database, and I could create this with this command, create schema and schema name, cell schema. So there is a very little difference between these two. Actually, this is the container. The database is creating the container, and the schema is actually the logical organization of the data. For example, HR, accounting, or any other organization of the data. But in SQL, both are the same, and they could create the database for us. Now, we will be creating it shortly, but let's see. As I explained, that database is the physical container and schema is its logical organization. But in MySQL, both are almost the same and can create the same database for us. When we are creating a database and then creating an object, a table inside a database, then we need to understand what kind of data we will have to store it. So for that, different kind of data types are available. Many data types are available, but here one category that we can see as the we will be having numeric, date and time, string, special, and JSON, and we are going to explain them briefly in the subsequent slides. The numeric data types, they are integer and they are integer and an integer, teeny, small, medium, and big, and similarly for fixed point, decimal, and numeric data types will be there, and for float and double will be there, and for bit storage we have bit, and for date and time we have date and date and time and date stamps, and we have other format like time and year, and these are its representation that how data will be stored. And for special type, for example, if we are dealing with the geometry and point, string, polygon, So these are the data types, and for special document representation we have JSON format. These are the data types that could be used for different applications. Now to create a table, first to create a database we need to use the statement. For example, let's say let me take it. Sorry. Create database and database name. For example, test DB. So this statement will create the database for us. And inside this statement, in this database and this test DB, for example, we will be creating these tables, vendor and product table, for example. So this is how a table could be created. For table creation, as we said, table and create table is the keyword and table name is the name of the table. And here we will be using different columns. For example, if we are going to create the table for the vendor, so all these are the columns we will be using, and then for each column we have to set the data types. So the data type that we have already discussed, and here we will be having constraint. So if we look into the creation of a database, of a table, we need two things. One is to set the data types for each column, and the second one is to apply different constraints. So the data types that we have already discussed, and the constraint we will be discussing shortly. And let's see. This is the vendor table. So in vendor table we have applied not null constraint to all the attribute that all the data is required, and for the vendor underscore code unique, because this is the primary key. And another concept here is at the end of this table we will be using primary key. We can also use the primary key if we want to apply it at the attribute level. We can also apply the primary key over here, as that before comma here I can, in front of this V code, I can write primary key, and then comma. So in that case we will be not writing it here. So this will create the vendor table, and here all these are the constraint, and this primary key is also a constraint. This is how we could create all the tables in our a database. And this is the other table, product. And in the product, one important thing is that how we could create the foreign key. So we can see here that this is v underscore code is the foreign key. So foreign key is always need to be written or defined at the end of the tables, because it is a table level constraint. But primary key could be written at the table level as well as at the attribute level. How foreign key could be applied? Foreign key is the keyword. And what is the foreign key? This v underscore code is that value, and it references to which table? To the vendor table. So this is that this foreign key is referring to this vendor table, and inside that vendor table to this attribute, v underscore attribute. And here one thing important is that on update cascade. So we will be shortly discussing that, what is cascade, update cascade and delete cascade. But this is the way how we could create table, apply the constraint and integrity rule. This is the integrity rule, and this is the referential integrity rule. This one, a primary key, is called the integrity rule, and this is a referential integrity. The foreign key is the referential integrity rules that we have to apply. Now, so this attribute, the constraint that I told you, that there are different kind of constraints, but the most important one are the integrity and referential integrity. Integrity, this is called the primary key constraint, and this is called the referential integrity is called the foreign key constraint. And at syntax we already discussed that primary key you will be writing just in front of the attribute is primary key and then the attribute inside the parenthesis. And the foreign key, for the foreign key we saw that you will be using the keyword foreign key in inside the bracket. You will be writing the attribute on which you are applying the foreign key, then the keyword references and to which table it is referencing, name of that table, and inside that table as the type of the attribute, to which attribute it will be referring. And so this is how we could apply them. Now there are three options when we are applying the foreign key, and these three options are they are very important to be learned and understand. The first one is on delete cascade. On delete cascade, the second one on update cascade, and the third one is nothing written in front of the foreign key. On delete cascade, we mean that if we have primary key and foreign key in two different tables and we have not written anything in front of it, in this case, the default case, neither delete cascade nor update cascade. So we cannot update the foreign key values, cannot neither delete the value from the main table nor update the value in the main table, mean the master table, if we have not written like this. But if we write on delete cascade, for example, at the end of this foreign key delete cascade, then what we could do that if we want to change the value in the main table, in the main table, in the child table, automatically those record will be deleted. And in case of update cascade, if we do changes in the main table to the foreign key, to the primary key value, that will be automatically reflected to all the tables where that for primary key appear is foreign key. So this is the advantage, and we will be demonstrating them with the example. And one thing, the last thing is that apart from this integrity constraint, primary key and foreign key, other constraints are also available. For example, not null. This is not null, which means that the value for this attribute is mandatory. Cust ID must have to take the value if we write not null in front of that. Unique, by unique we mean that we cannot add customer last name and customer first name should not be repeated for two persons in the same table. That is called unique. And default we mean that by default in this column, for example, area code, by default this value will be entered, and if you want to change that, you can change that later on. And the check constraint will check the list of the values. This is the key, check n. These will be used together. Check customer area code in this list. If the value is entered within this list, accept it, otherwise deny it. So these are the different kind of constraints that could be used for creation of the table. The last thing is that when we are defining constraint could either be defined at the column level or it could be defined at the table level. Column level mean that if you write it in front of the column, for example, this P underscore code, and in front of that you write the primary key. So this constraint is the column level constraint. But if you define it at the end of the table, mean primary key, and this is the code. So this kind of constraint is called table level constraint. And these constraint, the table level constraint that we are defining, they sometimes needs they need to have their own name. So two ways are available: use with or without their name. Here in this case, this primary key has its own name, product underscore p underscore pk. This is the name of this constraint, this primary key constraint. And constraint is the keyword. This is a professional way that when you are creating the database, it's better to define and create names for the constraint, because later on when we will be dropping these constraint or updating these constraint, we can easily do by its name. And if you don't have the name, we don't use the name, then the DBMS automatically assign the name from its own side. And so this is how we discussed that constraint with the name and constraint without the name. Both could be done. So this is all from our side, and we will be now implementing it in the next tutorial. Thank you.